Welcome back to the Deep Dive. So today we're looking at a tool that, honestly, if you just glance at the documentation, it looks incredibly dry. It looks like just another dusty config file from the, I don't know, the 1970s that somehow survived.
Because that is exactly what it is.
Right. But this is a huge, but if you're a developer or, frankly, anyone who works with complex systems and, values their free time, this tool is basically a superpower.
It really is.
It's the difference between doing things the hard way and, well, letting the machine do the heavy lifting for you.
It's one of those things that just sits quietly in the background of the internet. You don't see it, usually. But the moment you understand how it works, you realize it is literally holding the entire software world together. It's the glue.
We are talking, of course, about Make and the mighty Makefile. And to guide us through this, we're pulling from a technical guide simply titled Makefile.md. It's got, the works installation, demos, syntax.
Yep.
But it also references something that really caught my eye, the massive build file used by the Python programming language itself.
Which is an absolute beast of a file, an absolute monster.
We will get to that beast in a minute.
Yeah.
But I want to start with the problem, because nobody invents a tool like this for fun. They invent it because they're annoyed.
Exactly. Laziness is the mother of invention in programming. If you have to do something twice, you get annoyed. If you have to do it 3 times, you write a script.
So set the scene for us. Without Make, what is the life of a C or C++ developer like? Let's say I'm writing a program.
It's repetitive,
Yeah.
painfully so. Let's say you're writing a C program. You have your source code, maybe 3 or 4 different files. You make a tiny change to one of them. Maybe you just fixed a typo in a print statement.
Okay.
To test that, you can't just hit play like you might in Python or JavaScript.
You have to compile it first. You have to turn it into machine code.
Right. So you have to open your terminal. You type out a command to compile the source code into object files. Then maybe you have to type another command to link those files together into an executable. Then another command to run the tests. Then another to clean up the mess you just made.
And if you forget a flag or mistype a file name,
Then it breaks. You get some cryptic error message. And you're doing this every single time you hit save. It is the digital equivalent of washing a single spoon every time you take a bite of soup.
I love that image, washing the spoon between every bite. That is exactly what it feels like when you're manually typing build commands.
And imagine if you have 100 spoons. That's what a large software project is like.
So Make enters the chat. What is the high-level pitch here? How does it stop the spoon washing?
The pitch is, stop typing the same commands over and over. A Makefile is essentially a blueprint. It's a file where you define all those steps, how to compile, how to link, how to test just once, and then you just type one word, make.
And the computer executes the blueprint.
Precisely. But, and this is the key insight that I think a lot of people miss, it's not just a script.
Okay, let's unpack this, because to me it sounds like a shell script, just a list of commands. Why isn't it just a Dutch file?
That's the common misconception. A shell script is blind. If you tell a shell script to compile your code, it compiles your code. It doesn't care if you changed anything or not.
It just does the work.
It just does the work. It washes the clean spoons along with the dirty ones.
I see where you're going with this.
Make is smarter. Make checks to see if the work actually needs to be done. It looks at your files and says, hey, you haven't touched this part of the code since the last time we built it. I'm going to skip that step.
So it's conditional. It's actually making decisions based on what's changed.
It's dependency management. It understands the relationships between your files. And that logic, that efficiency, is what makes it the standard even 40+ years later.
That distinction is huge. It's the difference between a dumb checklist and a smart project manager who knows exactly what to do.
Exactly. It saves you from yourself, and it saves you time. A lot of time.
Now, the guide we're looking at today, it's definitely geared toward beginners, so it simplifies things. But I think it's important to establish the scale here.
Yeah.
We mentioned Python earlier. The source material points us to a file called makefile.pre.in at the Python GitHub repository. That's Python. Now, I'm guessing most people, they just download Python and run it. They don't think about how Python itself is built.
Right. Python is just software, and it's written in C. So to build Python, to turn that raw C code into the interpreter that runs your scripts, you need a build system. You need a Makefile.
And I'm looking at the reference to this file in the notes. It's not 10 lines long.
No. It is massive. It handles thousands of source files. It has to handle compiling on Linux, on Mac, on Windows, with all these different optimizations, different security flags. It is incredibly complex.
But it's using the same tool, the same basic make command.
It is built on the exact same principles we are going to discuss today. Targets, dependencies, commands. Whether you are compiling a Hello World program or maintaining one of the most popular programming languages on Earth, the mechanics are identical. It just scales.
That is wild to think about. It's like finding out the hammer you use to hang a picture is the same tool they used to build the Golden Gate Bridge.
Essentially, yes. And that's why learning this pays off. You aren't just learning a quirk of C++. You're learning how software is actually constructed.
Before we get into the nuts and bolts, the source mentions a resource for people who want to really deep dive after this. Makefiletutorial.com.
A classic resource, highly recommended. The syntax of Makefiles can be, let's call it particular.
Particular sounds like a polite euphemism for annoying.
It can be. It's very strict, so having a good reference guide is crucial because you will get stuck on syntax errors.
Well, let's unpack that syntax then. The core unit of a makefile is something called a rule.
The rule. Everything revolves around the rule.
And according to our breakdown, a rule has 3 specific components: the target, the dependencies, and the commands.
Correct.
Let's break those down because the naming can be a little abstract. Start with the target. What is that?
The target is the goal. It's usually the name of the file you are trying to generate. If we use a baking analogy, the target is the cake.
Okay, the cake, I could work with that.
In programming, it's your executable file, myprogram.exe, or maybe an object file. It's the thing that comes out at the end of the process.
Okay, so the target is the output.
Yes, exactly.
Then we have dependencies.
These are the inputs. These are the ingredients.
Right.
To make the cake the target, you need flour, eggs, and sugar. In code, to make the executable, you need your .c source files and your .header files.
And this is crucial for that smart behavior you mentioned earlier, right? The whole conditional thing.
Exactly. Make needs to know that the target depends on these specific files. That link is what allows it to check if anything has changed. If you don't list the eggs as a dependency, Make won't know to bake a new cake when you buy fresh eggs.
That makes perfect sense.
Yeah.
And finally, the commands.
The recipe, the actual steps. These are the shell commands, literally what you would type into the terminal that the system runs to transform the dependencies into the target. GCC, oh my program, source.c, or whatever compiler you're using.
Target, dependencies, commands. Seems simple enough.
It seems simple, but
Here comes the particular part.
there is a syntax rule here that has tripped up, and I mean this, literally every single developer since the 1970s. The source guide makes a specific point to bold this.
I think I know what you're going to say. It's the indentation, isn't it?
It's the indentation. The
Right.
commands in a rule must be indented with a tab character,
Not spaces.
not spaces.
So if I'm a neat freak and I like to hit the space bar 4 times to line everything up nicely.
It breaks. Makefile will throw an error, usually something cryptic like missing separator, and it won't run. It demands a literal tab character.
That feels so archaic. Why hasn't that been fixed? We have self-driving cars, but we can't use spaces in a makefile.
It's the famous bit of history. Stuart Feldman, the guy who wrote Make at Bell Labs in 1976, made that decision early on. It was a quick hack. By the time he realized it might be a problem, there were already about a dozen users at Bell Labs using it.
A dozen users.
A dozen. He didn't want to break backward compatibility for those 12 people.
You're kidding.
And because of those 12 people in 1976, we are all still hitting the tab key today.
That is incredible. It's like a butterfly effect of annoyance.
It is.
So listener, if your makefile isn't working and everything looks perfect, highlight the white space. Check your tabs.
Please, use the tab key. Save yourself the headache.
Okay, so we have our rule. We've managed to use the tab key. Now I want to go back to that smart logic you mentioned, the timestamps. This is really the brain of the whole operation. How does Make actually decide what to do?
This is the logic of efficiency. When you run Make and give it a target, the program asks 2 questions. Question 1, does this target file exist?
Okay, if I haven't built the program yet, the answer is no.
Right. So scenario A, the file's missing. Make says, well, obviously I need to build it, and it runs the commands.
Simple enough.
Question 2 is where the magic happens. If the target file does exist, Make compares its timestamp to the timestamps of all of its dependencies.
It checks if the ingredients are fresher than the cake.
Exactly. If you modified your source code 5 minutes ago, but the executable was built an hour ago, the source code is newer. The input is newer than the output. Make sees that and says, the target is stale, I need to rebuild it.
And if I haven't touched the source code? If the cake is newer than the ingredients,
Scenario B, the target is newer than the dependencies. Make looks at it and just says, everything is up to date, and it does nothing.
nothing is a powerful feature.
It is. Imagine that Python code base again. It has thousands of files. If you change just one file, you do not want to wait for the compiler to rebuild the other 999 files that haven't changed. That could take an hour.
Right, you'd be sitting there twiddling your thumbs
Mhm.
just for one tiny change.
Make realizes only one file is dirty, recompiles that one, links it in, and you're done in seconds.
So it's not just saving keystrokes, it's saving computational time. It's allowing for that rapid iteration loop that developers absolutely need.
Precisely. In a large project, a good makefile structure can save days of productivity per developer per year. That adds up.
That is huge. Okay, so I'm sold on the philosophy. I want this automation in my life. But Make isn't always installed by default, is it? The guide gives us a cross-platform breakdown.
It varies. It's a Unix native tool, essentially. So if you are on Linux or Mac, you're already halfway there, but you still might need to grab it.
Let's start with Linux. The guide mentions Ubuntu or Debian specifically.
On Linux, Make is part of the furniture, usually. But if it's missing for some reason, the guide tells us to use the package manager. Sudo apt install build essential.
Build Essential. I see that term a lot. What's actually in that package?
It's the starter pack for developers. It includes Make, but it also includes the compilers, JCC, G++men, and all the libraries you need to actually build software from source. It's the first thing you should install on a new Linux dev machine.
Got it. Now, Mac users, they have a terminal, but they don't always have the compilers.
Right, Apple wraps everything in Xcode, but downloading the full Xcode app is massive. It's gigabytes of data. You usually don't need the whole thing just to run Make.
So what's the shortcut?
The command is Xcode select install. It installs just the command line tools. That gives you Make, Git, and the compilers without the huge graphical interface. It's much, much lighter.
Much better. And finally, Windows. Windows always has to be different.
Yeah, Windows doesn't have a native history with Make in the same way. So the source recommends using a package manager called Chocolatey.
Which is like apt or homebrew, but for Windows.
Exactly. You open an administrator PowerShell and you just type choco install Make. It grabs a version of Make that's been ported for Windows and sets up your path variables so you can run it from any command prompt.
Simple enough?
Yeah.
Choco install Make. I love how friendly that sounds. Here, have some chocolate and also some build automation.
It's a great package manager, and once you run that, you have the Make program available in your path, just like on the other system.
Okay, we are installed. We're ready. Now we need to create the file itself.
Mhm.
And the source is very specific about this part.
Yes, the naming here is strict. You create a file in your project root, no extension, no .txt, no .o'shea, just Makefile, capital M.
Just make file.
That's the default name. When you type Make in the terminal, the program automatically looks for a file with that exact name in the current directory. You can name it something else, but then you have to pass a flag to tell Elemer, Make where to look. It's just easier to stick to the default.
Stick to the default.
Got it.
Oh, okay. Let's look at the demos provided in the source material. There's a folder called Makefile Demos with 5 examples. Let's walk through the first one, which is basically the hello world of Makefiles.
Demo 1. It's very simple. It defines 3 rules. Compile, run, and clean.
These seem like pretty standard categories.
They are conventions. You will almost always see a clean rule in any real-world Makefile.
What does clean actually do?
It's the janitor. The build process creates all these temporary files, object files, executables. Sometimes you want to nuke everything and start fresh, just to be sure. The clean rule usually contains commands like arm or delier to remove all those build artifacts.
So if I want to run that specific rule, what do I type?
You type make compile.
If I want to compile, what happens if I just type make? Just the word, nothing else.
Good question. If you don't specify a target, Make executes the first rule it finds in the file.
Ah, so the order in the file actually matters.
Order matters a lot. Usually, developers put a rule at the very top called all, or maybe the name of the main executable, so that the default action is build everything.
That makes sense. Now, there's a bit of a quirk in how these demos are presented in our source material. The author used a Jupyter notebook.
Which is an interesting choice for this topic.
Yeah, usually I see Jupyter used for Python data science, plotting graphs, that kind of thing. But here, they are using it to run C++ code and make commands.
They're using what we call magic commands or shell escapes. You'll see lines in the source starting with an exclamation point, like .make.
Right.
That exclamation point tells the notebook, hey, don't run this as Python code. Pass this command to the underlying system shell. It works for a tutorial, but I want to be really clear to you listening. You do not normally build C++ code inside a Jupyter notebook.
It's a teaching tool here, not a production environment.
Exactly. Make is a command line tool. You run it in your terminal. If you try to do this in a professional setting inside a notebook, people will look at you funny.
And actually, the source points out a glitch that happened because of this notebook environment.
Yeah.
The mysterious case of Demo 5.
Right, Demo 5. The source notes that Demo 5 fails to execute properly inside the notebook environment. It just hangs or errors out. You have to go to the actual terminal to run it.
Why would that happen?
It's likely an issue with how the notebook is handling environment variables or interactive prompts. When you run make, it expects a standard shell. The notebook is a layer on top of that shell, and sometimes things just get lost in translation.
Which honestly reinforces the point. These tools rely on a standard shell environment. When you wrap them in layers like a notebook, sometimes the signals get crossed.
Exactly. The environment matters. Make expects a standard Unix-like shell behavior.
We've covered a lot of ground here. We've gone from the philosophy of laziness to the syntax of tabs to installation and even debugging Jupyter notebooks. But I want to zoom out for a second.
Sure.
A lot of our listeners might not be C++ developers. They might be writing Python or JavaScript or working in data science. Why should they care about Makefiles?
That's the big takeaway. Make isn't about C++ say, it's about a concept called the directed acyclic graph, or DAA.
Okay, let's unpack that. That sounds like something from a PhD thesis. Directed acyclic graph.
Yeah.
What does that mean for me?
It just means understanding that task B cannot start until task A is finished, and task C needs both A and B to be done first. It's about mapping the dependencies of your work.
So this applies to anything.
Anything. I know data scientists who use Makefiles to manage their entire data pipelines. The rule is basically, don't train the model until the data is cleaned. Don't clean the data until the raw CSV is downloaded.
And Making handles that logic automatically.
Perfectly. It handles the logic of, if the raw data file hasn't changed, don't waste time in computing power cleaning it again. It applies to generating static websites, writing LaTeX documents, even deploying microservices.
So it's a universal logic. Define the task once, describe the relationships, and then let the machine handle the execution.
And respect your own time. We spend so much energy keeping these mental checklists in our heads. Did I run the build script? Did I move the files? Did I update the images?
And then you forget one step and suddenly everything breaks and you don't know why.
Exactly. Put it in a Makefile. Get it out of your head and into the code. Document your process as code.
I love that. Get it out of your head. That is the ultimate productivity hack. It frees up your brain for the actual creative work.
It really does.
So here is my final thought for you to chew on today. We started by talking about that Python Makefile. This one file, makefile.predentin, manages the build process for an entire programming language. It is incredibly complex, dealing with OS quirks and thousands of files. Yet, it follows the exact same simple rules we discussed today. Target, dependencies, commands.
It's the same structure. It just scales way, way up.
So my challenge to you, the listener, is this. You probably have a task in your workflow right now, something you do every day. Maybe it's resizing a bunch of images, maybe it's aggregating logs, maybe it's just organizing your downloads folder. It's annoying, it's repetitive, and you do it manually.
The spoon washing task.
Exactly. Go find your spoon washing task and ask yourself, could I write a make file for this? Could I define the target, the dependencies, and the commands and just type make?
I bet you can. It takes 10 minutes to learn, and it saves you hours over a lifetime.
And once you do, you'll never go back. Thanks for diving in with us.
See you next time.